minus 150 microstrains, and shear strain gamma xy, that is 120 microstrains. So I repeat, the state of the plane strain at a point is represented by epsilon x, which is 250 microstrains. Epsilon x is 250 microstrains. Epsilon y is minus 150 microstrains, and the shear strain gamma xy is 120 microstrains. So the question asks you to determine the principal strains and the orientation of the element. ठीक है जी? Question asks you to determine the principal strains and the orientation of the element. So before we start, the first thing we need to do is we need to determine the center point of the Mohr circle. So first step is we need to determine the center point of the Mohr circle. So guys, can you please calculate the center point of the Mohr circle? Center point of the Mohr circle has coordinates average strain and zero shear strain. So average normal strain and zero shear strain. So can you please first of all calculate average strain, average normal strain? So
Sir,
average
50
normal strain, good. 250 microstrains and minus 150 microns. So average strain is 50 microstrains. So the coordinates of the point C are, coordinates of the point C are, Ji Akib,
50 and 0.
50 microstrains and 0. 50 microstrain and 0. Okay, done. Now next is we need to write the coordinates of the reference point A. Coordinates of the reference point A are epsilon x and gamma xy by 2. ठीक है जी? Coordinates of point A, which is our reference point, that is when epsilon x and gamma xy by 2. So that's the case when over x dash axis coincides with x axis. ठीक है जी? So that is epsilon x dash is equal to epsilon x, and epsilon y dash is equal to epsilon y, and gamma x dash y dash over 2 will be equal to gamma xy over 2. ठीक है जी? So the reference point A has the coordinates will be epsilon x and gamma xy by 2. The important point to be noted here, whatever are the signs, ठीक है जी? Whatever is the sign of epsilon x and gamma xy, the same signs will be used as the coordinates of the reference point A. So epsilon x is 250 microstrains. Epsilon x is 250 microstrains. Fine. And gamma x by 2 will be, gamma xy by 2 will be 120 over 2. So that will be 60 microstrains. So reference point A coordinates are 250 microstrains and 60 microstrains. Is this point clear?
Yes, sir.
Yes, sir.
ठीक है जी? The only point to be noted here that whatever are the signs of epsilon x and gamma xy, you have to use the same signs. ठीक है? Whether positive, negative. Here they were both positive. Fine. So your coordinates of reference point A are epsilon x 250 microstrains and 250 microstrains, and gamma xy by 2 is 60 microstrains. Okay. Next step, please calculate the radius or resultant. Do you know the formula of radius, or should I show you the formula? Okay, please calculate the radius, or you can say the resultant of the Mohr circle. So please calculate and let me know the answer. The formula is under root under root epsilon x minus epsilon y over 2 square plus gamma x y over 2 square. Epsilon x is 250 microstrains, epsilon y is minus 150 microstrains, and shear strain is 120. Shear strain is 120 microstrains. ठीक है जी? So please calculate the radius or the resultant.
Sir, 208.8.
Okay. To when you will be drawing the Mohr circle, I would suggest you to keep the answers in like round figures, no decimal place. So 209 micro strains. 209 micro strains. ठीक है जी? So radius or the resultant of the Mohr circle is 209 micro strains. True? 209
Yes.
microstrains.
Yes, sir.
ठीक है जी? Now,
Yes, sir.
come back to the question. So the question asks you to determine the principal strains and the orientation of the element. So now we will draw the Mohr circle. ठीक है जी? Because this you have drawn 50 microstrains, average strain. Resultant you have calculated as 209 microstrains. ठीक है जी? You have the coordinates of point A, point C. You know the radius. You can draw the Mohr circle, and then we have to calculate the principal strains. So let's draw the figure. ठीक है जी? In the paper, you need to bring your compasses.
Okay, sir.
Just whiteboard is opening. ठीक है जी? One thing in the Mohr circle is that you need to keep the x scale on the both axes same. ज़्यादा ही गलत बन गई है. ठीक है जी?
Sir, whiteboard is not visible.
वो error आ गया. Just a moment, please. Just a moment. Cannot display the content. We could not start the presentation. Let me do it again. मेरे पास भी error आ गया. All right. Now can you see it?
Yes, sir.
So, ठीक है. Two hundred. 250. 300. ठीक है जी? On the negative side, we can have minus 50. Because average point is 50. ठीक है जी? Average strain 50 minus 209 somewhere we need 200 तक चले जाते हैं. So this is epsilon x. Epsilon x is, this is gamma by 2. Okay. So first we have to locate the center point 50. Okay, this is your center point C. Then comes the reference point 250, 250 and 60. So somewhere here. ठीक है जी? This is your reference point A. Then we have to draw the Mohr circle now. So this is 209, so should be somewhere here. Plus 209, 50 plus 209, 259 over roughly. Somewhere here. And 50 minus 259. ये वाला जरा पॉइंट चेक कर लें 50
Yes, sir. 159.
159. Okay. So more circle, yes. आज कुछ सही नहीं बना सर्कल, चले वो जरा हो ही जाएगा. Okay ji, so now our target is, this is your point B. Let me mark this. This is your point B, where's your Mohr circle bisects the horizontal axis. This is your point D. ठीक है जी. This is your radius. ठीक है जी. So this is R. So now in the question it is asked that we have to determine the principal strains. ठीक है जी. So this is your epsilon 1, which is the larger value. ठीक है जी. So epsilon 1 कितना है जी? I can
259.
50 plus 209.
259.
जी, ठीक हो गया. So basically, if you recall yesterday when we were studying the formula for the calculation of the principal strains, it was average strain. ठीक है जी. It is, sorry, it's causing a lot of problem today. Average strain plus the resultant. So this is 259 micron strains nu s, और ये आपका E2 या epsilon 2 ये बन जाएगा आपका 50 minus 209 और एक सेकेंड, और ये है आपका epsilon average माइनस आर, और ये कितना बन रहा है जी, माइनस 159,
Yes, sir.
Yes, sir.
minus 159 microstreams. Minus 159 microstreams. Now, next is we have to calculate the orientation of the principal plane. So, moving from the reference line CA, ठीक है जी, moving from the radial reference line, let me change the color. So moving from the radial reference line CA towards CB, this will be 2 theta P1. So can you please calculate this? And then moving from here to here will be your 2 theta P2. ठीक है जी, so please calculate tan 2 theta P. Tan 2 theta, tan 2 theta P1 क्या होगा जी ये, if you use simple trigonometry, coordinate of point A कितना था आपके पास, that is 250, ठीक है जी, so 250
Sir, 16.7. Sir,
एक सेकेंड, एक सेकेंड जी, 60 over 250, वर्किंग भी तो शो करनी है, if someone is not getting, फिर तो सही नहीं रहता,
Sir, 209.
ठीक है जी, ये 250 minus 50, बेस आ गया, परपेंडिकुलर इज 60, ऐसे ही है,
Sir, 259 minus 50.
yes, sir.
259 नहीं
नहीं
होगा,
सर,
250,
250 ही आना,
ये
250 ही
ट्रायंगल
आना.
ये वाला बना, 250 ही आता है, 259 नहीं आता, tan थीटा कितना आया, 2 थीटा p,
सर 2 थीटा p की वैल्यू है ये 16.7.
एक सेकेंड ओके, 2 थीटा p1 is 2 theta p1 is 16.7 is correct,
6.
हाँ
Yes, sir.
16.7 ये करेक्ट है, और आपका थीटा p1 बन जाएगा 8.35 डिग्री, करेक्ट है, ठीक है जी,
Yes, sir.
ये इसको रख कर देते हैं. नाउ लेट्स मूव टू द नेक्स्ट क्वेश्चन. अब थीटा p1 is 16.7, सो थीटा p2 आपका कितना होगा, 16.7 प्लस 90, तो वो हो जाएगा जी 106.7 थीटा p2. अगर
सर
आप
इसमें
कहते हैं,
सर 90 में तो हम सर 90 में तो 8.35 ऐड
सॉरी
करेंगे ना.
सॉरी हाँ सॉरी सॉरी 8.35, सो एक सेकेंड मुझे पहले यहाँ पे फिर लिख लेने दें. थीटा p1 is theta p1 is 8.35 degrees, and theta p2 is 98.35. ठीक है जी, 98.35. Okay, now next move to the next question. ठीक है जी, we already got these answers. ये सारा हो गया. Now the same question, same data. The state of the plane strain at a point is represented by the components epsilon x is 250. The same, it's basically the same question. 250 microstrains, epsilon y is minus 150 microstrains, and gamma xy shear strain is 120 microstrains. So the same question, you are also required to calculate the maximum in plane shear strains and the orientation of the element. ठीक है जी, so let's calculate that one as well. Let's start. So we need to calculate the ठीक है जी, so this is your point E. This will give us the maximum shear, maximum in plane shear strain. This is point F. So point E is gamma by 2, gamma by 2, and that is equal to कितना है जी? Gamma by 2 is equal to basically just the radius.
209.
Correct. 209. और gamma कितना हो जाएगा आपका maximum in plane shear strain? Gamma is 209 into 2. ये gamma by 2 है ना?
418.
18, yes. Or 18 microstrains. So this is your maximum in plane shear strain. Then the orientation of the shear planes moving from the reference plane CA moving from the reference plane CA towards CE. So this angle will be 2 theta S1. 2 theta S1 will be equal to 90 degrees. 90 degrees minus 2 theta P1. ऐसे ही है जी?
Yes, sir.
Yes, sir.
3.3.
So 2 theta S1 is equal to now 90 minus 16.7, 73.3.
Yes.
Yes, sir.
कितना? और आपका थीटा S1 कितना हो गया?
36.65.
36.65
6
कितना कह रहे हैं
65 65.
Okay, ji. With this numerical is finished. This was example. Let me write it. This was example 10.4 and 10. ठीक है जी. Now next topic we are going to study is absolute maximum shear strain. Absolute maximum basically shear strain. So let's start the next topic. Guys, this question we can also do this one. This I have forgot that we haven't. What we are going to do, guys, what we are going to do, this question we have done. Okay, ji? This one we have done. Maximum in plane shear strain and orientation of the shear planes. The other thing we can do, I'm not going to change the data. I'm going to use my own data of 10.4 and 10.5, which was epsilon x 250 microstrains, epsilon y minus 150 microstrains, and shear strain 120 microns. And what we are going to do, we are going to determine the state of the strain on an element oriented 20 degrees clockwise. ठीक है जी? 20 degrees clockwise. 20 degrees clockwise means theta is minus 20, and this is theta on element. So theta on the Mohr circle will be 2 times of this, minus
40.
20 into 2, minus 40. ठीक है जी? minus 40. So
Yes,
इस
sir.
part को भी कर लेते हैं. Let's go back. Minus 40. So if we use another color here, चलें. ये कर लेते हैं, चलें. Done हो गया. So this angle is ये 2 theta p1 was 16.7. 16.7. ठीक है जी? So 16.7 from moving from the reference line CA in the clockwise direction 40 degrees. ठीक है जी? 40 degrees. 40 degrees. ठीक है जी? Approximately if you can see 2 theta s1 is 73.3 3. So 40 degrees will be, I am doing it approximately because I do not have a compass. But when you guys will be doing it, you will use the compass. So approximately this much angle, let's say, is 40 degrees. This one. ठीक है जी? Fine.
Yes, sir.
So we can calculate the coordinates of this point. So coordinates of this point will be coordinates of this point will be 180 microstrains comma, and on the vertical you can have
120.
120. ठीक है जी? So this is your point P basically. ठीक है, और ये आपका एंगल जो है ये बेसिकली आपका बन जाएगा 2 theta 40 degrees. Now let's move to the absolute shear strain. So you can see here in the book, because we have already studied it, so you can see they are giving just very little explanation, but I will give you, if you require, we will draw what you say the figures as well, in the individual figures. So absolute maximum shear strain in section 9.5, that was basically about the absolute maximum shear stress. It was pointed out that in the case of the plane stress, the absolute maximum shear stress in an element of the material will occur out of the plane when the principal stresses have the same sign. Basically, what we are saying for this case, like this case, they are saying when both the principal strains, or like both the principal stresses sigma 1 and sigma 2, they are positive. When both the principal stresses sigma 1 and sigma 2 will be positive, what will happen? That your absolute maximum shear stress, ठीक है जी, the larger of the three, 1 2 3, the larger of the three, absolute maximum shear stress, ठीक है जी, and maximum in plane shear stress, they will be different. Maximum in plane shear stress will include sigma 1 and sigma 2 both, ठीक है जी. This is what we have studied. So that's why they are saying that the maximum shear stress, absolute maximum shear stress, this will be absolute maximum shear stress, and this will be lying in the plane xz, so it is considered as out of the plane. So the absolute maximum shear stress in an element of the material will occur out of the plane when the principal stresses have the same sign, means either both the stresses are either tensile or compressive. If both are tensile, both are positive, you will have figure on the right side. If both are negative, you will have the figure on the left hand side. But the absolute maximum shear stress and maximum in plane shear stress remains the same. Now, in case of the plane strain, if the principal in plane strains cause elongations, means if both the principal strains are positive, epsilon 1 and epsilon 2, both are positive, ठीक है जी, then or you can see it here, it's resulting in the elongation of the element. It is resulting in the elongation of the element. So if the principal in plane strains cause elongations, Then the three Mohr circles describing the normal and the shear strain components for the elements oriented about x dash, y dash, and z dash axis are given in the figure 1013b. This one. Now you see, we know that over epsilon 1 will always be over maximum in plane, will always be your larger value of the principal strain, and epsilon 2 will always be your smaller value of the principal strain. So if both your principal strains are positive, they are causing the elongation, then epsilon 1 is positive, larger value, epsilon 2 is positive but smaller value. So first we are going to draw the Mohr circle due to, you can say, epsilon 2. So z on the z-axis principal strain is 0, so only along the y-axis you have the positive principal strain. So you will get this smaller Mohr circle, this one. Then corresponding to epsilon 1, that is your xz plane, along with that xz plane, along the z direction your principal strain is 0, and along the x direction you have epsilon 1. So 0 to epsilon 1, this larger Mohr circle represents epsilon 1, which is xz plane, and the absolute maximum shear strain for this case will be this one, gamma xz over 2. Then for the third scenario, xy plane, in which you have epsilon 1 and epsilon 2, you will connect epsilon 1 with epsilon 2 and you will get this Mohr circle. And maximum in plane shear strain in this case will be gamma xy by 2. ठीक है जी, and this is your maximum in plane shear strain because it includes both the two principal strains, and your absolute maximum shear strain will be the one which will include uh, will be the one which is larger of the three. So larger of the three is this one, gamma xz maximum, gamma xz maximum. So now you can see this gamma xz maximum, its formula will be basically epsilon 1 minus 0 divided by 2. ठीक है जी, so this is basically epsilon 1 over 2, which is equal to gamma xz over 2. So epsilon 1 over 2 is equal to gamma xz over 2. 2 in the denominator will cancel out. So your absolute maximum shear strain will become equal to epsilon 1. So that's why they are just writing epsilon 1, because 2 in the denominator will cancel out. Is this point clear?
Yes, sir.
And your maximum in-plane shear strain will be, in this case, will be epsilon 1 minus epsilon 2 over 2, epsilon 1 minus epsilon 2 over 2, which is equal to gamma xy over 2. 2 in the denominator will cancel out. So your maximum in-plane shear strain for the case when both your principal strains are positive, that will be epsilon 1 minus epsilon 2. ठीक है जी. So the absolute maximum shear strain, absolute maximum shear strain will be epsilon 1, and this value gives the absolute maximum shear strain for the material, and it is larger than the maximum in plane shear strain. It's very obvious from the figure, as this is maximum in plane shear strain, this is absolute maximum shear strain. So this is epsilon 1, ठीक है जी, and this is epsilon 1 minus epsilon 2 over 2. ठीक है जी, any questions about this?
No, sir.
Okay, now in the second case, you have epsilon x is positive and epsilon y is negative, so resulting into, you can say, epsilon 2, the minor principal strain is negative and the major principal strain epsilon 1 is positive. Now consider the case where one of the in-plane principal strains is of opposite sign to the other in-plane principal strain, so that epsilon 1 will cause elongation. Remember one thing, epsilon 1 will always be the larger strain. So when you say one is positive, one is negative, so epsilon 1 will be positive, epsilon 2 will be negative, because it will be resulting in the contraction. ठीक है जी, and corresponding to this you will draw the Mohr circle, and you can see this one including epsilon 2. This is basically your yz plane, because epsilon 2, which is negative strain causing the contraction in the element, it's acting along the uh, y-axis, y plane, and along the z plane you have zero principal strain, so 0 to minus epsilon 2, ठीक है जी, and your maximum in plane shear strength in this case will be 0 minus epsilon 2 over 2. And then for this second scenario, for this case where you have what you say epsilon 1, ठीक है जी, that will be xz plane. Principal strain about the z axis, about the z plane is 0, and about the x is epsilon 1, so 0 to epsilon 1. So this maximum in plane shear strain will be equal to epsilon 1 minus 0 over 2. So this is your uh, maximum in plane shear strain for xz plane. Then for xy, which includes both epsilon 1 and epsilon 2. So this you will connect epsilon 1 with epsilon 2. So this larger Mohr circle, basically this larger Mohr circle represents what you say xy plane, Mohr circle for xy plane, and the maximum in plane shear strain for this xy will be this one, ठीक है जी, xy over 2. Now the thing is that in that case where you have one principal strain positive and other principal strain negative, in that case you can see the absolute maximum shear strain is the larger of the three. So this is this one, gamma xy over 2. And of course, the maximum in plane shear strain is the one which includes both x and y axis, means which includes both epsilon 1 and epsilon 2. So in this case, your maximum in plane shear strain and absolute maximum shear strain, they will be same, and that will be epsilon 1 minus epsilon 2 over 2, ठीक है जी, and that is equal to gamma by 2. So 2 in the denominator will cancel out, so your maximum shear strain and absolute maximum shear strain will be epsilon 1 minus epsilon 2, ठीक है जी. Is this point clear?
Yes, sir. Yes, sir.
So we may therefore summarize the above two cases.
Yes, sir.
Guys, okay, we may therefore summarize the above two cases as follows. If the in-plane principal strains both have the same sign, ठीक है जी, the ये case one आपका आ गया, ये वाला, this one, both the principal strains have the same sign, uh, both have the same sign. The absolute maximum shear strain is this one, which is x z plane, and the maximum shear plane, maximum in plane shear strain is this one, xy. So in that case, the absolute maximum shear strain will occur out of the plane and has a value of absolute maximum is equal to epsilon maximum. That is basically epsilon 1. Okay? And however, if in the in-plane principal strains are of opposite signs, then the absolute maximum shear strain equals the maximum in-plane shear strain. ठीक है जी? This one. Both the absolute maximum shear strain and maximum in-plane shear strain have the same value. Guys, this paragraph is very important with respect to the quiz. ठीक है जी? ये वाला. ठीक है? Any questions?
No, sir.
No, sir.
Okay. Then this numerical we have to do the state of the plane strain at a point is represented by the strain components. Epsilon x is minus 400 microstrains, epsilon y is 200 microstrains, shear strain is 150 microstrains. You are required to determine the maximum in-plane shear strain and the absolute maximum shear strain. Uzair,
Yes, sir.
Yes, sir.
how will you proceed in this question?
सर फर्स्ट ऑफ ऑल
इसको
तो
देखें और मुझे
मैं
जी
सर सर एक हमारे पास नॉर्मल स्टिचेस पॉजिटिव है, एक राइट साइड पे बन जाएगा और एक लेफ्ट साइड पे बन जाएगा। दो डिफरेंट मोर सर्कल्स हमारे पास बन जाएंगे।
first of all
और
first, first of all let me explain it. Guys, in this question, first of all, you will draw the Mohr circle. ठीक है जी, आपके पास epsilon x है, you have epsilon y and gamma xy. You will draw the Mohr circle. ठीक है जी, Mohr circle. To draw Mohr circle, first you will calculate the average strain. That will give you the coordinates of point C. Then you will have the coordinates of point A minus 400 microstrains and 75 microstrains. ठीक है जी, we will draw the Mohr circle. Fine. Then we will calculate the principal strains epsilon 1 and epsilon 2. ठीक है जी, जब आपके पास epsilon 1 and epsilon 2 value you will get it, then you will see that whether both your principal strains have the same sign or different sign. ठीक है जी, if they have let's say if they have different sign. So larger value will be epsilon 1, negative value will be epsilon 2. Then you will draw the either you can draw the Mohr circle for that for individual component, ठीक है जी, or you can use directly the formula. When you have what you say opposite signs, the absolute maximum and maximum in-plane shear strain is epsilon 1 minus epsilon 2. I think we will I think we need to do this question ourselves so that uh, we can have a better practice. Uh, guys, section B. I have arranged an additional lecture from 2 to 4 today. So after your professional ethics class, we will have a 2 hours additional class today. So both section C and section B are required to come into the class at 2 o'clock today. ठीक है जी, 2 o'clock,
Okay, sir.
2 to 4.
Okay,
Okay,
And
sir.
sir.
we will start with this numerical. Thank you very much because section B has PRC lecture. Section C you are free. ठीक है, we
Okay,
will
sir.
I will see you guys at 2 o'clock. 2 बजे class होगी.
Okay, sir.
ओके सर।
Allah Hafiz, sir.